Lokesh. Welcome to Tutor Lokesh channels. So in this video we are going to derive the equations of motion, the three equations of motion which are very much used in physics, which are v is equal to u plus at and s is equal to ut plus half at square and v square minus u square is equal to 2as. And I'm going to derive in two different ways, and one is by using the traditional way, where we will derive by using the equations and the definitions from the definitions, and the other method by is by using from the graphs. Okay, now let me derive using the equations. Okay, so we have three equations of motion. Let me write the heading. So one is v is equal to u plus at, and second is s is equal to ut plus half at square, and third is v square minus u square is equal to 2as, where I'll write the notations, or I'll write the notions of these symbols. U means initial velocity, u means initial velocity, v means final velocity, v means final velocity, and s is displacement. S means displacement. Don't think that S stands for speed. So the first letter of speed is S. So don't think that S is speed, because here we assume that S is displacement or sometimes distance. Okay, for distance and displacement we use the same letter S, but commonly it is used for displacement. Okay, not for velocity. Okay, don't ever remember the formula, the symbol of speed as S. S stands for only displacement. Okay, now A is acceleration, and T is time period, or time taken, or time of journey, whatever it may be. Now let me start with the definition of displacement. Okay, then I'll derive all these equations. Yeah, we know that displacement is the shortest path, whereas distance is the actual path travel. For example, if a body is moving from A to B like this, so the actual path travel is known as distance. Distance is nothing but the actual path traveled. Where displacement is the shortest path, and usually it is a straight line path between 2 points. The straight line path between 2 points is usually the shortest path. Okay, so I'm not discussing about here scalars and vectors. Let me confine to this derivation. Okay, I'm not taking much time. So this straight line path is known as displacement. Okay, shortest path or straight line path between 2 points is known as displacement. It is, which is denoted by the letter S. Remember, displacement is denoted by the letter S. Okay, now the rate of change of displacement is known as velocity. So let me write that. Okay, velocity, the definition of velocity, usually we will denote it by V, no matter whether it is initial velocity or whether it is final velocity. Whenever the term comes velocity, we will denote it by letter V. Velocity is nothing but the rate of change of displacement with respect to time. The rate of change, the rate of change of displacement, the rate of change of displacement with respect to time is known as velocity. So velocity v is equal to rate of change of displacement, that means the change in displacement over a period of time. So we'll denote it by delta s by delta t. That means final displacement minus initial displacement by final time minus initial time. Okay, so usually we'll write it as delta s by delta t for some time taken. Okay, now, and acceleration, usually we can, for big values or from like approximate values, we'll take it as s by t, where s indicates s2 minus s1 and time indicates total time taken, s by t. Okay, here s is not the displacement at any point. Here s indicates s2 minus s1. This s2 minus s1 I am taking it as s, and this t2 minus t1 I am taking it as t. So I can write v as s by t. And similarly, acceleration is defined as the rate of change of velocity. Acceleration is defined as the rate of change of velocity. The rate of change of velocity with respect to time. With respect to time. So a is equal to delta v by delta t, or v2 minus v1 by t2 minus t1, where this v2 is known as final velocity and this v1 is known as initial velocity, and this initial velocity we are assuming it as u by total time taken by time t. Now here starts our definition and derivation of the equations of motion. Okay, now from the definition of acceleration, it is very clear that acceleration is nothing but rate of change of velocity with respect to time. That means change in velocity by time. So a is equal to, in a simple way we can tell that a is nothing but change in velocity with respect to time. So that means v minus u by t. Now to get the first equation, we need to write equation for v. So what I have to do here, t is being divided. If it goes to that side, it will become multiplied. So a into t will become at is equal to v minus u, and therefore if you write the equation for v, this minus u will go to that side and will become add. So v is equal to u plus at. v is equal to u plus at is the first equation of motion which we are deriving from the definition of acceleration. So v is equal to u plus at. So here we got the first equation derivation proof. Now coming to second equation, we know the second equation is s is equal to ut plus half at square. Let me derive it. Okay, and before deriving it, we need to know what for we are deriving. We are deriving the equation for s, where s is meant by displacement. Okay, now assume that a body is traveling in a straight line. Assume that a body is traveling in a straight line, and the initial velocity is u and final velocity is v. Initial velocity is u and final velocity is v, and the time taken by the body to reach from this point A to B is time t. Time t. Remember, there is no other velocity. Okay, there is no other velocity. For example, in different cases or different problems, we have certain scenarios like this. For a distance of 10 kilometers, it will travel with a velocity of some u1, and for a distance of 20 kilometers, it will travel at a distance of u2, and for a distance of some other 10 kilometers, it will travel at a distance of u3. Now then, if you want to find average velocity, then you have to use other formula, because average velocity is nothing but total displacement by total time taken. Total displacement, average velocity is total displacement by total time taken or total time traveled. And similarly, average speed is total distance by total time taken. But this formula is applicable when a body is having different speeds for different journeys. Here we are having only one journey from point A to point B, and the initial velocity is u and final velocity v. Even if you apply this formula, total distance by total time, we will get the formula as S average. That means we need to write equation for S, right? So S means displacement. So total displacement is equal to average velocity into time. Average velocity into time. Now total displacement is denoted by letter S, is equal to average velocity. When we have only a single path of journey and initial velocity is u and final velocity is v. Remember, when we have a single path of journey, not like this, when we have on a single path of journey and if the initial velocity is u and final velocity is v, the average velocity is nothing but u plus v by 2, average of velocities into time t. Because okay, average means we know that I mean from the maths formula or mean or statistics. Okay, so average is nothing but sum of numbers by number of numbers. So if there are two velocities, it will be u plus v by 2. Okay, so a plus b by 2, like that. Or even you can apply this formula also. You will end up with the same equation. Average velocity means u plus v by 2 for a single path journey. Now we have already derived that v is equal to u plus at in equation 1. We have already derived that v is equal to u plus at from equation 1. So I will substitute here. I will substitute in place of v. So therefore s is equal to u plus, in place of v I will substitute this v value as u plus at. So that will become u plus at whole divided by 2 times t. So that will become s is equal to u plus u 2u plus at by 2 into t. Now I will just split the denominator for both of the numerator terms. So s is equal to 2u by 2 plus at by 2 into t. So then it will become 2 gets cancelled. So s is equal to u plus at by 2 into t. So when you multiply with t, u into t, ut plus at into t, at square by 2, and that by 2 we can write it in front. So that will become s is equal to ut plus half at square. S is equal to ut plus half at square. And again we will derive the equation v square minus u square is equal to 2as. Okay, let me consider the displacement again. So we'll start with the displacement. So the average displacement, total displacement is equal to average velocity into time. So average velocity means u plus v by 2 into time. But in this equation I don't have any time. In fact, instead I have acceleration. Okay, so now I'll check whether I can convert this time in terms of acceleration. So if you want to convert time in terms of acceleration, you must see the definition of acceleration. So yeah, since a is equal to v minus u by t, I can write this t as v minus u by a, right? a is equal to మనకి v minus u by t ఉంది. ఈ t అవతల పోతే a కిందకు వస్తుంది కదా. So t can be written as v minus u by a. I will substitute this in the third equation. We know that a is equal to v minus u by t. So therefore t is equal to v minus u by a. So I will substitute t value as this. So s is equal to u plus v by 2 into v minus u by a. Now so by doing multiplication, that will become v plus u into v minus u, v square minus u square by 2a. So v square minus u square is equal to 2as. So that is equation 3. So in this way we can derive the equations